We are 2B.3 exponential and log forms of equations. These notes you got today, and they're going to go on your handy dandy page 78. If you didn't use all of your 77 yesterday or touch it, you can draw me a pretty picture or write me a beautiful note, whatever your heart tells you to do. Okay. Sorry about your heart. Okay. All right. So today we're going to do exponential and log forms of equations, which means that we're going to be toggling back and forth between logs and exponents. Okay. As we see here, it says it is important to keep in mind that whenever we are dealing with logs, we should think about them in terms of exponents. Okay. The base of the log tells us the base of the exponential expression, and the argument of the log is the value that we want the exponential equation to equal. So at the top of your paper, you should have this written: definition of a logarithm. Yes? Yes. Do y'all have it on your paper, right? It says if b and n are positive numbers, b cannot equal 1. So we can't have a log base of 1. No? This is our quiz? Yes. What were you doing? I did this. All right. That was interesting. Here we go. So when we're going from a log to an exponent, there are things that we got that help us remember what we're doing. So your base of your log is going to be the base of your exponent. Do you see that? Yeah. Base to base. Your argument of your log, so your argument becomes your result. Okay? Your result becomes your power. So when we're converting from log to exponent, the base is going to be the base. The argument's going to be the result. And your result's going to become your power. Now, when we're going reverse the other way. So here on exponent, your base becomes your base. Your power becomes your result. Do we see that? I can't write very well. And then your result becomes your argument. That's what that's called.
This is great. I have no idea what this is.
Argument. Okay?
Are we just matching the...
We're just rewriting and making sure we understand how to go back and forth. Okay? So log to exponent, we have a base power result. Exponent to log, we have base argument result. Okay? All right, let's look at our example. So up first, we have log base 2, 8 equals 3, and they want us to write it as an exponential. We're going to do 1 and 2 together, and then you're going to do 3 through 6 at your table, okay? Should take you under 60 seconds to do it. Got it? Yes. Okay. All right, so first up, we're going to identify our base. What's our base? What's our power? What's our result? You know you did it right if it makes a true statement. It's 2 to the third equal to 8. Yeah, that's a true statement. Okay? Yes? You're with me? Okay, let's number 2. What's my base? What's my power? -2, and it equals 1/4. That's 2 to the -2 equal 1/4. Yeah. All right, so you're going to about 60 seconds to do 3 through 6. Ready? Go. Right? Do we need the other 30 seconds? Yeah. We're good? All right, so on, number 3. Perfect. Number 4. Awesome. 5. Great. 6. All right, so major takeaways here. I want you to understand anything to the 0 power is going to always be 1. A fractional power means you're taking that root. So the cube root, the fourth root of 16 is 2. That means 2 times 2 times 2 times 2 equals 16. Again, a fractional power means you're taking that root. So this is asking what is the cube root of 8? And the answer is 2, because 2 times 2 times 2 equals 8. 8. All right, let's go the other way. We got it. We're going to be done. We have plenty of time. All right. Going the other way. So now we're going from an exponential to a log. So we start off with log. We need our base. What's our base? What's our argument? What's our result? Bam. So base, argument, result. Mm-hmm. Because you're on log. All right, 8. -1. All right, another 30 seconds. Go. Talk to each other, check with each other. Base, argument, result. Base, argument, result.
That just confused me. Did I do that right? Yep, I did. Is that it?
All right, are we good?
Yeah.
Okay, number 9, what we get?
Oh,
There we go. So we got log base 32 equals, 2 equals 1/5. My 32 got kind of big. Log base. Perfect. Log 864 equals 211. Perfect. 12. Perfect. Okay. Key takeaways here. Anything that takes the log of 1 is going to automatically be 0. Any base with log of 1 is going to be 0. Any log whose argument and base are the same is going to automatically be 1. If the base and the argument are the same, it's going to be 1. Got it? All right. Why is this important? Well, this is important when we want to solve. So having that skill is important for when we're solving. So up first, we're going to write a math sentence here. And we're just going to not really write the math sentence. We're just going to write equals x. It's now a math sentence. Okay, log base 5 of 25 equals x. In order to solve this, we're going to convert it to an exponential. How can I convert this to an exponential? Perfect. So therefore, what is x? Perfect. We solved it. Was that terrible?
Nope.
Let's try it again. We're going to make this a math sentence. Here we go. An equation. Bam. Log 464 equals x. What is x? How do I write that as an exponential? 4 to the power x. X equals 64. So 4 to what power is 64? 3. Good job. Okay, that means 4 times 4 times 4 equals 64. Still with me? All right. We have 15. We're going to make it into a sentence, a situation here. I need to write that. How do I write that? And what is the answer here?
nothing.
Good job. Why?
Negative.
It's negative. It is undefined. We cannot have an exponential equal to a negative. Do y'all remember that from number 10 on your assignment yesterday? Okay. All right, here, we need to find our x. Well, how do we rewrite that? So what is x? 3. Good job. 3 to the power of x equals 1/3. Okay. 1/3 can also be written as another way. How can I rewrite 1/3? 3 what? If I want it to be 3/1, it has to be 3 to the -1. If I want to take that 3 out, so notice here, what is x? -1. Anytime you have a number in the denominator, to take it out of the denominator, you make it a power of -1. So the answer is -1. The last two, you're going to do at your table. Ready? Go.
I'm done, mister. I finished my work.
You did?
Yeah,
How does it feel?
good.
Was it terrible?
You know, this week I haven't been behind on anything.
And you've done minimal complaining. I mean, you've still done some complaining, but it's been less than normal.
I just know.
Oh, she really don't want you to play anymore.
My complaining rubbed off. I don't know.
All right,
The 16.
here we go. What happened? So this one, you rewrite it as an exponential, you get 9 to the x equals 3. How can 9 to the x equal 3? It has to be a fraction. Why does it have to be a fraction?
Because it gets smaller.
You can get smaller. It needs to get smaller, so x has to be a fraction. What fraction? 1/2. You're taking the square root of 9. So x has to equal 1/2. Okay? So keeping that in mind here, when we set this equal to x, we have 16 to the x equals 1/2. I have to make this smaller and what? And negative. It has to be smaller and negative. Otherwise, will this result as a fraction? No. So if I do 1/2, that means the square root of 16 is 4. Is that what I need? No, I need to go smaller, right? Okay, what about 1/3? Is it a number times itself 3 times? That will equal 16. So 1/3 is asking a number times itself will equal 16. Is that true? No, there isn't a number that's going to do that. What about 1/4? Yes, and that number is what? 2 times 2 times 2 times 2 equals 16. So we know x is 1/4, and because it's a fraction, it makes it a -1/4. Okay, so wanted to be mindful here. If your result is getting smaller than your power, that means that it has to be a fractional. If there's a fraction as the result, that means there has to be a negative. And that concludes 2B.3. On your Canvas, I sent you guys an extra credit assignment for this unit. It's over 2B.2 and 2B.3. If you would like that extra credit opportunity, it's sent to you on Canvas and it's due by Monday. Okay.